Hello guys, welcome to this video. So I'm giving you an application of Gauss reduction, and to do that we want to use Gauss reduction to find the determinant of the matrix A given here. Okay, so in this video I want to show you the step to Gauss reduce first a matrix before you obtain the determinant. Okay, we want to transform the matrix into an upper or lower triangular matrix. That's what we mean here by Gauss reduction. And most of the time we will reduce into an upper triangular matrix. Means that we want the lower non-diagonal to be 0. So we want this 2, minus 1, 2, 2, 1, and minus 2 to become 0. That's the role of the Gauss reductions here. To start, I want to get rid of these 2. To get rid of this, the objective is to find a determinant, as I say, right? And the determinant is given by this bar. So we fix the first row. This is 1, 0, 4, and 6. Then I want to get rid of this. I want this 2 to become 0. How can I do that? So I want this R2. I want to modify the second row in such a way that this second row contains 0 here. So I want the second row to become second row minus 2 first row. So basically, because we have 2 here, then I want to multiply this first row by 2 and subtract from the second row such that we have 0 here. Okay, so by doing that we have 0 because we have 2 minus 2 is 0. Here is 5 minus 2 times 0 will be 5. Here we have 0 minus 2 times 8. This is minus 8. And the last one we have 3 minus 2 times 6. So 3 minus 12 is minus 9. Okay? Now for the third row, I want to get rid of this minus 1. So I can just say the third row become the third row plus the first row. So if we sum up this, because we already have negative sign here, if we sum up, you have 0. Here we have 2, 7, and 11. For the last row, we want to get 0 here. We do the same, something similar to the second row. So this is R4, become R4 minus 2R1. Okay? So this is 0. This is 1. This will be minus 2. Minus 2 times 4, so this is minus 10. And the last one, this is 3 times minus 2 times 6. Minus 2 times 6 is minus 12. Plus 3, this is minus 9. All right, we have done with the first column. Now let's move to the second column. We want to get rid of this 2 and 1. So we have to rewrite the first row and the second row as it is now. So this is 1, 0, 4, 6, 0, 5, minus 8, minus 9. So here we are fixing the second row to solve the third and the fourth. So here we have 2, here we have 5, and here we have 1. So to get rid of this, we have to choose the third row to become third row minus this, so this will be 2 over 5 second row. Okay, so basically you see we choose the third row. We want to take this third row, subtract by this one, so that's why we have this coefficient. The coefficient from the third row over the coefficient from the second row, all multiplied by the second row here. Okay, this is 0, 0. So this is R3 minus 2 over 5 times minus 8. You give 51 over 5. And for this one, we have 11 minus 2 over 5 times minus 9. This is 73 over 5. Now let's look at the last one. For the last one, I want to get rid of this one. So this R4 become R4 minus 1 over 5 because we have ones here. So 1 over 5 R2. So doing the operation, we have 0 here. Here we also have 0. In here, minus 42 over 5 and minus 36 over 5. All right, we are getting there. So now we move to the third column, okay? And for the third column, I want to get rid of this term. I want this to become 0. So here we have A. Of course, we just have to repeat the first row, second row, third row. The first row is 1, 0, 4, 6. This is 0, 5, minus 8, minus 9. The third one is 0, 0, 51 over 5, and 73 over 5. Now, for this to become 0, so for this to become 0, we first have to fix the third row and then solve for this one. So this will be R4 minus, so this will be minus times this minus is become positive. So do we have 42 over 5 divided by 51 over 5. So we can just take the inverse, right? The multiplication, the division of two fractions. So this becomes 5 over 51, R3. Then this leads to 0, 0, 0, 82 over 17. Yes, if you do the multiplication correctly, you must get this 82 over 17. Now we're almost done. So the determinant here, we have the upper triangular matrix we're looking for. So determinant is just a product of the diagonal element. This is 1 times 5 times 51 over 5 times 82 over 17. This is equal 246. Yes, this is correct. All right, so this is every time when you have to do Gauss reduction, you have to follow this step, okay? Be careful when you do these manipulations. You can see that every time I have to, for me to solve this, I have to fix the first row. All right? So when I'm on the first column, I'm doing the manipulations on the first column, I have to fix the first row. In here, when I'm doing the manipulation on the second column, I have to fix the second row. And lastly, here I'm manipulating the third column, so I have to fix then the third row to do that. So you can see here, as I say, 2, we have 1, 1, 1. Second column, we have R2, R2. And the third column here, we are using the third row, R3. So don't forget, don't mix up the procedure. You won't be able to get the correct solution. All right, this is all for this video. I'll give you more examples in the following videos. Okay, or we'll solve some tutorial questions, and hopefully you'll be able to practice more on this Gauss reduction, and yeah, and get ready for your exam. Cool, thank you.